Okay, this is the first part of the central nervous system. I believe, let me take a quick look. There are 6 parts to this. So, the central nervous system, we've already identified in the previous chapter that is made up of the brain and spinal cord. So obviously then this chapter we're going to focus more in depth on the brain and the spinal cord. So how do we tackle going over the brain, which incidentally is the only organ that seeks to understand itself? So the brain is made up of this wrinkled, and we're going to get into these wrinkles made up of hills and valleys. And if we take a look at the surface anatomy, we can kind of break this up. And the reason why we're breaking it up is because this is kind of how I'm going to approach covering the brain. We're going to go over the cerebral hemispheres, something called the cerebellum, and then the brainstem. The cerebral hemispheres we're going to spend quite a bit of time on. So just don't forget that once we're done with that, we're going to circle back and cover the cerebellum and then the brainstem. And these two are a little bit quicker, okay? Also, in terms of spelling, just make sure that you don't get cerebral and cerebellar confused. All right, so when we talk about the brain, embryonically, in your textbook, they'll talk about these vesicles. And there are these primary vesicles that start off and then they end up as secondary brain vesicles. And this is kind of what we see. I'm not going to go over the embryonic development. Just keep in mind in future chapters, there are going to be certain parts of the body that are actually made from a downgrowth of hypothalamic nervous tissue, such as the pituitary gland. It's actually this combination of a superior growth of oral mucosa and a downgrowth of hypothalamic nervous tissue to form this one organ. But sorry for that. Regardless, we have these secondary brain vesicles, and this is what we're going to focus on. So we're just going to cover, as we go over these cerebral hemispheres, we're going to cover the telencephalon, diencephalon, and then the meson, meton, and myelencephalon. Sorry, so these would be the cerebral hemispheres. And then this area in here would kind of be the brainstem, okay? So we're just kind of going over this and then kind of using this as another mechanism with which to kind of structure how we're going to cover these. So the fates of these secondary brain vesicles are just listed here. And keep in mind, we're not going to cover all of these, like the basal nuclei, I am not going to cover. So when we cover the cerebrum, our focus is going to be on cerebral cortex, the white matter that's in there. When we cover the diencephalon, it's going to be the thalamus, hypo, and epithalamus. And then these last 3 are really the brainstem, and we will cover them. Also associated with these vesicles, and just watch how you're talking about this, are going to be ventricles. Ventricles are cavities of the brain. And these cavities, they're going to be lined with, and we'll get to this a little bit later, they'll be lined with specialized blood vessels called choroid plexus, and they produce CSF, cerebrospinal fluid, and that's really just a hypotonic filtrate of blood. And so wherever the CSF is, we already know that they're going to be lined with these ependymal cells. All right. So these cavities, these ventricles of the brain, we're going to have these lateral ventricles, a third ventricle, a cerebral aqueduct, which just connects the third to the fourth. And then there's also something that connects the lateral ventricles to the third ventricles, but really that is just kind of a whole. If you're wondering where this nomenclature came up with, how come we have these lateral ventricles and then a third and a fourth, it is actually one of the few times anatomists got together and said this nomenclature is ridiculous and hard for anatomy students, because the way it was originally set up was that the lateral ventricles, there's 2 of them. The right one was considered the first ventricle, the left one was considered the second. And they said that's ridiculous, let's just call them the lateral ventricles. And then the nomenclature for third and fourth stuck. These will also be on your lab list so that you'll be able to better appreciate how they connect. And we can see this here. So here are these lateral ventricles, okay? And then there's going to be this interventricular foramen, and that's what just connects these lateral ventricles to this third ventricle. Cerebral aqueduct connects the third to the fourth. And then basically the continuation of the fourth is going to be that central canal. And that runs right through that spinal cord. So when they do a spinal tap, they're trying to take a look at CSF. That's what they're trying to get to, that central canal. And we'll get to this part when we cover the spinal cord. Again, our focus, at least initially, is going to be on the brain part. What we will do, though, just globally, our 10,000-foot view, is I just want to talk about the patterns of tissue, how we see the organization of tissue in the brain, and how we see the patterns of tissue in the spinal cord. So the spinal cord, we have this central cavity, right? That's that canal surrounded by a gray matter core. So we have gray matter and then surrounded by white matter. The brain is just like this, but it has additional areas of gray matter. Right? So for the cord, this is gray, this is white, this is very rudimentary. We have this is gray, this is white, and this is gray. So the brain just has an extra layer in the cortical tissue, an extra layer of gray matter, right? All right. So we're going to start with these cerebral hemispheres. We're going to start kind of basic and then get a little bit more complex. So these cerebral hemispheres, that wrinkled tissue, they're going to be these hills or these ridges. They're called gyri. And a singular one. Let me see if I can. I don't even know if really that works. Single one is a gyrus, and grooves that are the sulci. A single one is a sulcus. Really not going to test you on singular versus plural. Just on your lab list, there's the central sulcus and a precentral gyrus. So just so you that understands that. Also, when we're covering surface anatomy in lab, there are going to be deeper grooves that are called fissures, right? So what separates these cerebral hemispheres is a very deep groove that we call the longitudinal fissure. Each hemisphere has three basic regions: cortex, white matter inside, and the basal nuclei. And again, the basal nuclei we're not going to be covering this time around. And that's the end of part one. So what we're going to be doing for part two, and I really think, even if you're not using my outlines, I would say this would probably be a good time to at least use the outline so you can see how these things are structured and what belongs to what. So we're going to cover the cortex and then the white matter. But there are many subdivisions in each of these, and that's where I think the outline may help. All right, so that's the end of part one.